Good morning. I'm Kumar. Welcome to my YouTube channel. We have provided this service free for last 15 years with 20,000 videos. I'm really grateful to all my 200,000 plus subscribers and so many other active participants who have been sending their request. In this particular video, I have taken requests from a student from Seattle, USA. She wants to understand how do we solve 3D related questions. So we'll talk about 3D related questions, a simple approach. As you know, every day I go for morning walks and I mix my nature with mathematics. The passion of wildlife and math comes together in my YouTube channel. Here is another very beautiful amalgamation of the two. So let us look into a 3D question and see how do we solve such a question from the very basics. Here, back to the classroom, we have a question right there which says 3D trigonometry. We'll try to solve a question which is based on height and distance. And we are going to learn about what are bearing angles, how do we sketch a 3D position of different elements, how do we relate the bearing angles and solve the word problems, what is the angle of depression, and then we will solve the related triangles to find distances between the objects. So I was actually taking this video from a bridge and over me was this bald eagle. I call it eerie. Well, the picture which you see on the screen, the eagle and the fawn, it looks scary, right? It seems to be extremely scary, just as the 3D questions are for some of the students. Well, look here. We have a very friendly approach which is going to help you understand the situation. So let me just frame the question first and then we are going to solve it. Here is the question for you. It is based on 3D high distance application. Eerie, the bald eagle, is inspecting her territory. She is 60 meters above the river and sees two deer enjoying in the Humber River. From her position, the antler brandy has a bearing of 110 degrees and the young stag Andy has a bearing of 230 degrees. Erie estimates the angle of depression of 40 degrees for Andy and 37 degrees for Brandy. How far apart are the two deer? That's the question for you. Can you solve it? Make an attempt. Well, here is an approach to solve such questions. We have used the term bearing angle. Well, some of my students do not really understand what a bearing angle is. And therefore, I'll take a moment to describe what a bearing angle is. Here is another example with another bird. So what you see here is a bird which is the beautiful white heron. It is at the bearing of 335 degrees. As you can see, the bearing angle basically is measured from north, right? So that is the north for us, is measured from north clockwise as we have shown here. So this angle from north is 335 degrees. You get the idea. So that is how we see the bearing angles. Perfect. So I think you have understood what bearing angle is. Also remember that when we talk about the bearing angle, it should always be written in 3 digits, right? So we use 3 figures to write a bearing angle. So that is to say, if we are talking about a bearing of 45 degrees, that is the direction northeast, I will write it as 045 degrees. You understand? So let me again now define the bearing angle for you, which is bearing angle is commonly used in navigation, that is the application, and the angle in degrees measured clockwise from north is what we call as a bearing angle. Perfect. Three figures are always used to write the bearing angle. So that summarizes what you need to know about the bearing angle by sketching, right? So the rough sketch is there for you, which will help you to really sketch the right diagram. Perfect. But I'll show you in steps how do we really sketch a 3D application questions diagram. So we will always draw a line which will be kind of like this, indicating that this is our direction north on the XY plane, kind of 2 dimensions, which is our table at present. Is that okay? So that is the north direction, and the east direction will normally be shown like this. Right? So this becomes the east direction. You get the idea when we are drawing a 3D figure. And right here, the height will be shown by a vertical line. Look here. It seems as if we are looking at the corner of a room, right? So we have the height and the XY axis, which gives you 3-dimensional effect, right? Now, we have the bald eagle right there on the top, and the distance is 60 meters. So we know this is 60 meters for us. So that is the distance directly from the eagle to the floor. Clear? Now we are given 2 deer. So one of them is placed at a bearing of 230 degrees and the other one is placed at 110 degrees. So from north, so this is the north which we are talking about, right? So from north, if I have to make 230 degrees, where will it be? Well, so if you go like this, that is 180, correct? Now 180 is this direction. Somewhere more than 180 is 230, correct? So it will be kind of here. So let's say that is the position along this line, that is to say, right? So I will say along this line we have one of the deer. Perfect. So this is what we are saying is 230 degrees. The other deer is at a bearing of 110 degrees, right? So 110 degrees is less than 180, more than 90. So between north and east it is 90 degrees. So we have this direction here, kind of 110 degrees. Is that clear to you? Perfect. Now those are the 2 positions. So we can just take some position here with respect to the bird Erie. Now it is also given to us that the angle of depression for the 2 deer is 40 degrees and 37 degrees. So it is 37 degrees for Brandy. So let's figure out what was the angle for each. So Andy was here and Brandy was somewhere in this direction. For Brandy, the angle of depression estimates 30 degrees for Andy, 45 degrees for Andy, right? So 45 degrees for Andy. So let's see, how do we draw this 45 degrees for Andy? So when you're talking about the angle of depression, in that case, we'll draw a line horizontal from the bird parallel to the axis, right? The horizontal axis rather, right? So let me just make a line parallel to horizontal axis. Is that clear to you? Right? Now, from here, angle of depression means from the horizontal. So it is 40 degrees from there, correct? So we can draw a line 40 degrees from there. Does make sense to you? So that is the 40 degrees angle of depression. Perfect. So that is the position of one of the deer. From the other side, let me draw the angle of 37 degrees, right? So this is the horizontal line, and angle of 37 degrees will be kind of like this. Do you see that? So this angle here should be 37 degrees. So that is how we draw the angle of depressions, right? Now, these are the angles of depressions, right? In the diagram, they look like the angle of elevation. So this will be again 40 degrees, same as the angle of depression. On this side, that will be 37 degrees, same as the angle of depression for that. Do you see our diagram being formed? So what do we have here? So let me now sketch this diagram in bold. So that is the position of the bird Erie. Now this is one of the deers, which is Andy, the other deer which is Brandy, right? So those are those deers, right? So We have that. Now, since this is in two different planes, that is 90 degrees for you. Remember that. This is also 90 degrees for you. Now, we have to calculate. So I think the diagram is absolutely clear to you. What did we do? Well, we first located the bird's position, which was 60 meters above, right? And then we located the position of the two deer using the bearing angles, which were in the horizontal plane. And then we dropped the line, this eyesight line, as the crow flies, which gave us the bearing angle of 40 degrees and 37 degrees. That gave us the exact location of the two deer. Now what do we need to find? Distance between them. Perfect. So let me complete the diagram. I'll just join A to B, and that is the distance D, which we want to calculate. Well, you can see it does form a triangle, correct? With center at the origin O, and what we need to know is the angle which AOB makes. So that is the calculation which we have to do. Can you help me to find what is the measure of the angle AOB? Well, let's figure it out. Well, AOB is 230 degrees minus 110 degrees, correct? That is what it is, right? So if I do that, so we get what? 0 take away 0 is 0, 3 minus 1 is 2, and we get 120 degrees. So this angle is 120 degrees, perfect. So we get our angle, which is 120 degrees. So in this particular triangle AOB, we actually only know the angle 120 degrees. How do we find the sides AO and the side OB? Well, we could find this by solving the triangle AO and the position of the bird, right? So let's call this position of the bird as E, right? So I hope you have understood this strategy. How do we draw a position for 3D word problem, correct? So we began with the bird Erie, which was at the height of 60 meters, and from there it had located two deers at position A and B. Their positions were given with respect to the bearing angles, and from those bearing angles we also found the angle between the two deer and the origin. The angle of depression, which is same as angle of elevation, formed in the vertical triangles EAO and EBO, help us to actually solve this particular question. Now we are going to see how do we really solve the question using trigonometry. Perfect. So let's move on and understand the strategy involved. So here is a small sketch of what we just worked out. Here, let me add, we have got 40 degrees as angle of elevation now from the deer A, and from the other deer we have 37 degrees, correct? We know the height of the bird is 60 meters above, and the angle between the two deers with the origin is 120 degrees, correct? So that is what we figured, right? Now to solve this, from where should I begin? Well, definitely I should begin with the triangle where I know one angle and also the opposite side. I can use the tangent ratio to find the sides AO and BO, correct? So we could write tan of angle A, which is 40 degrees for us, as the height over AO, correct? And from here, we can say that AO is basically equal to the height over tan A, right? In our case, AO will be equal to height of 60 meters divided by tan of 40 degrees, correct? So that is how you can get AO. So we can work this out using a calculator. It gives me 60 divided by tan of 40 degrees, right? So I'm just calculating on the calculator. I get 71.50. Let me write 71.5 for this particular case. Similarly, I can find what is B2O, right? So B2O will be equal to what? Well, B2O will be the same height of 60 divided by the angle, in this case which is 37 degrees, correct? So using the same logic that tan B is equal to height over BO, we can cross multiply and find what the length BO should be. Using the calculator, we will get what? 60 divided by tan of 37, and that is equal to 79.6. So we get 79.6 meters as the length of BO. Now we look into the triangle AOB. Now in this particular triangle, I know that AO is 71.5 and BO is 79.6. And the angle in between is 120 degrees. Perfect. Now how do we solve this triangle? It is not a right angle triangle. What should we do? Well, we could use sine law or cosine law. Which law will work for us? Well, some of you may not recall how to use sine law and cosine law. So let me take a step back here and share with you what exactly sine law and cosine law is. So, what is sine law? As you may remember, a over sine A equals to b over sine B equals to c over sine C, that is equal to a constant, right? So that is sine law. The cosine law is that a square equals to b square plus c square minus 2bc cos A. Now, in this particular case, which one will be used? Well, here we know the two sides and the included angle. When you know two sides and included angle, in that case, you should always apply cosine law, correct? So we are going to apply the cosine law in this particular case and use these formulas. Is that clear to you? Perfect. So let's move back to our question. So in this particular case, we are going to apply the cosine law, right? And the cosine law, we can find AB square as equal to AO square plus BO square minus 2 AOB cos of angle A, and everything within square root, correct? That is how we are going to calculate. So we can just substitute the value and calculate the result. Clear? That is how we are going to do it. So now we'll just substitute the value. So what we have here is, because I square root it, so let me write AB, the distance required. So AB basically equal to the square root of, let me write down the values. We have 71.5 square plus we have 79.6 square minus 2 times 71.5 times 79.6 times cos of 120 degrees, correct? So we'll substitute all these values and calculate using the calculator, correct? So let me do it. So we have 71.5 whole square plus 79.6 whole square minus 2 times 71.5 times 79.6 times cos of 120 degrees, correct? So equal to the result square root, answer equals to, gives me around 130 degrees. It is in fact 130.91. So that is the distance between the two. So we found that the distance can be written as approximately 131 meters between the two deers. Is that clear to you? So we use the cosine law to find the solution at the end. So I hope you have understood this solution. We began with a scary looking question, right? Where the eagle was looking at the two deer. We are given the angle of depressions for both the deer and also the bearing angles. We actually drew a sketch, a rough sketch, to locate all the three important characters in this particular diagram. We worked out the angles and then the sides using the cosine law. I hope you have understood the strategy to solve any 3D question. And this particular diagram, which I have sketched before you, can be actually used for any similar question. I hope you understand and appreciate it. Feel free to write your comments, share your views, And if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.